Hello everyone, today we're looking at the process of multiplying and dividing algebraic fractions and the simplification of these fractions. Now, before I go into this video, I think it's important that we understand the methods of multiplying and dividing fractions and also looking back at how to simplify algebraic fractions, which we've seen in previous videos. So if we look at the example in the top left-hand side, we have a question here where we are multiplying our two fractions together. Now, when you multiply two fractions together, all you do is you multiply your two numerators and then you multiply your two denominators together. So 4 times 5 is 20, 5 times 6 is 30, and then very simply here, we can cancel out here or simplify these fractions by dividing the numerator and denominator by 10, giving us an answer of 2/3. Now, with dividing fractions, slightly different in the sense that there's one slight change we do for this. Now, some people may have come across the process of keep, change, flip. Some people use this KCF method or KFC. I generally like to say that when you divide fractions, what you are doing is you are multiplying the first fraction by the reciprocal of the second, i.e. you are multiplying this fraction by its inverted or flipped version, which we call the reciprocal. We then multiply through, as we've done before, 3 times 8 divided by 4 times by 7 gives us 24 divided by 28. And once again, we can simplify this fraction down by dividing the numerator and denominator by 4. We divide this by 4 and divide this by 4, giving us an answer of 6/7. So that's the process of multiplying and dividing fractions. You either multiply the numerators together and the denominators together, or you, if in the case of division, you flip the second fraction, you multiply it by the reciprocal. Question on the right hand side is a algebraic fraction that was originally quadratics that have been factorized into 2 double brackets. And what we can see is that we can actually divide the numerator and denominator by x minus 2, or we can see these x minus 2 simply cancel out. That leaves us with a final answer, a final simplified fraction of x plus 4 divided by x plus 3. You can keep these in brackets if you want to, but you don't have to. I think it's better to put them in brackets as well, just for sort of better notation as such. So if we now apply all of this together into a few questions on multiplying and dividing algebraic fractions, we have these two examples ahead of us. Now, if we look on the left-hand side, this is a division question. So when we are doing division, we have to use the process of changing the division to a multiplication and flipping this fraction and turning it into its reciprocal. If you want to use, as I said, keep, change, flip, you can do. But we get 4a squared b over c times by c to the 4 divided by 6a. When we multiply fractions, we said you simply multiply the numerators together and multiply the denominators together. So that gives you 4a squared b c to the 4 divided by 6ac. Now, having multiplied this through, it's about simplifying down and cancelling things out. So if we think about this, c to the 4 and c may be able to cancel out, or bits of that. A squared and a may be able to cancel out. 4 and 6 may be able to cancel out. So we can see for 4 and 6, these are both divisible by 2. Divide by 2 and divide by 2. That gives us 2 as our numerator and 3 as part of our denominator. A squared divided by a is the same as a times a on the top and a on the bottom. If we think of our rules of indices, a squared divided by a to the 1 is 2 minus 1, leaving us with just a on the numerator. We then have c to the 4 divided by c, which is going to give us, if we think of our numerators again, so if we think about our indices as well, c to the 4 minus c to the 1 is c cubed, and we also have this value of b, which has not cancelled out at all. And there we have it. We now have on the numerator 2abc cubed divided by 3. That is a fully simplified algebraic fraction. Now, we're going to bring it to the right-hand side. This is now a multiplication question. So we are going to multiply our numerators and multiply our denominators for this question. However, some of you may notice that if we look at our numerator on the right-hand side, we can cancel out, or we can factorize from x squared plus 3x a value of x. And we can also factorize from this 8x plus 8 the value of 8. So what I'm going to do over here is I'm actually going to factorize that over here, x brackets x plus 3 divided by 8 brackets x plus 1. Now, if you notice, there's actually an x plus 3 on the denominator over here and an x plus 1 cubed on the numerator over here. So actually things are going to cancel out. Now, we did say this is a multiplication of fractions question. So if we are multiplying fractions, we are going to be multiplying the numerators by the numerators and the denominators by the denominators. So I'm actually going to extend this fraction over here. And I'm going to write this out in full. X plus 1 cubed is actually 2x brackets x plus 1, x plus 1, and x plus 1. And on the denominator, we have x plus 3. Now, what some of us may notice if we look at the top, we've got an x plus 1 and an x plus 1 over here, and an x plus 3 and an x plus 3 over here. That means that we can actually cancel out some of these things over here. If we cancel out our x plus 3 with our x plus 3 and cancel out our x plus 1 with our x plus 1, we can now tidy this up again on the top. If we look at what is left on the top, we have 2x, another x, making 2x squared, and then x plus 1 and x plus 1 giving us x plus 1 squared. On the denominator, we just have this value of 8. So there's one last thing that we can cancel out or simplify in this case, and that is the 8 and the 2. Both of those are divisible by 2. So if I divide this by 2 and divide this by 2, I get x squared brackets x plus 1 squared divided by 4. So what we've seen over here was a method of factorizing these questions down to make it easier for us when we want to cancel out later. And actually, that's a very important point when it comes to these kinds of questions, when it comes to simplifying algebraic fractions via multiplication and division. So I'm now going to apply this to two other questions, two final questions to have a look at. One is a multiplication and one is a division. Now, we end up introducing quadratics into this case. So for quadratics, we need to factorize out and factorize into double brackets. So if we look at the left-hand question, we have over here x squared plus 6x plus 5. We need two values that multiply to make 5 and add to make 6. That's x. That's 1 and 5. So our top bracket over here is going to be x plus 1 brackets x plus 5 divided by x plus 2. Now this is multiplication, so I'm actually going to just extend my fraction line there, my vinculum as it's called, along and factorize out the right hand side as well. If we look at x squared plus 3x plus 2, again we need two values that multiply to make 2 and add to make 3. That's 1 and 2, so we get x plus 1 brackets x plus 2 over here, and we have over here x squared plus 9x plus 20. We need to factorize that, find out two numbers that multiply to make 20 and add to make 9. Well, that is going to be from 20, 5 and 4. 5 and 4 add to make 9x. So that's going to be x plus 4 and x plus 5. This is now a manner of simply cancelling out the common factors from the numerator and denominator. So we can see here x plus 5 and x plus 5 are common. X plus 2 and x plus 2 are common. And that is complete. That has been fully factorized or fully cancel down. So now we simply need to bring this all together and finish up our question by collecting what is on the numerator and the denominator. On the numerator, we've got x plus 1 times by x plus 1. That is x plus 1 squared. And on the denominator, we just have x plus 4. That has been fully simplified, and we can leave it like that. That looks very neat and tidy. Now, what we've seen here was a multiplication of algebraic fractions with quadratics. We are now going to apply the same principle to a division style question. But I'm just going to bring it slightly more complicated quadratics to factorize. We've seen previously the method or the AC method to factorize these. I'm not going to do it for this question in particular. I'm just going to show you what happens once we've factorized. So if we look at the quadratic that we have in this case, first of all, this is a division question. So we do need to rewrite this as a multiplication question instead. So 3k squared minus 5k minus 2 over 4k squared minus 1 times by 2k squared plus 3k plus 1 divided by 3k squared minus 2k minus 1. This is now a matter of factorizing out these quadratics and then simplifying down, just like we did in the previous example. Now, the first quadratic, 3x squared minus 5k minus 2, can factorize down to 3k plus 1 and k minus 2. The denominator is actually the difference of two squares. That means that's 2k, because 2k squared gives us, so 2k all squared gives us 4k squared, and 1 times 1 is 1, so that's 2k minus 1 and 2k plus 1. And because we're multiplying, I'm just going to extend my fraction line, or I said the vinculum, across. And once we've extended that, we can factorize the right-hand side to give us 2k plus 1 and k plus 1. And on the denominator, we end up with 3k plus 1 and k minus 1. And now, once again, last step here is to cancel out the factors that are common on the numerator and the denominator. So looking through, we can see here I've got a 2k plus 1 up here and a 2k plus 1 over here. I've got a 3k plus 1 over here and a 3k plus 1 over here. So we now look, there are no common denominator, there are no common factors on the numerator and denominator. Our numerator is k minus 2 and k plus 1. And our denominator is 2k minus 1 over here and k minus 1 over here. And that is complete. That is the full process, and that is generally as challenging as it gets. What we've done is we've applied the division step by flipping our fraction over here, or multiplying by the reciprocal, or using keep, change, flip, then factorizing out our quadratics, factorizing them down, and eventually cancelling them out to leave us with this final answer. I hope that's made sense. If it hasn't, please leave a comment below, or please message me directly. Thank you very much.